Hi guys, my name is Ian and today we are going to be looking at updating the bootloader in an Arduino Nano. We're going to cover how to do it and why you might want to do it. First thing though, what is a bootloader? A bootloader is just a small piece of code that runs when the Nano is started up, and its job is to check if there's a new sketch being downloaded. If there isn't, run the existing sketch that's in Flash. Why might you want to update the bootloader? Well, I want to update it because I needed to use the watchdog timer recently for a project, and I discovered that with the old bootloader the watchdog doesn't work. It crashes the Nano and only a repower of it will recover it. There are other reasons why you might want to update the bootloader. One of them is the new bootloader is smaller, so you can get some flash memory back, 1.5K to be exact, which might have 32K, ain't too shabby. Another reason you might want to update it is the new bootloader is a faster download speed. It's 115K baud instead of 57.6. So how do we do it? Well, what I'm going to show you today is simple verification that the bootloader is broken, as in I will show you the watchdog. I've got a sketch with the watchdog timer being triggered, and I'll show you it crashing the Nano. Then I'll show you how to update the Nano's bootloader, and at the end we'll run the same watchdog check sketch again to see that it's fixed the problem. So let's have a look at the Nano. So what you can see at the minute, this is my Nano. It is running the a watchdog testing sketch that I have written. The sketch is quite simple. It has a countdown, counts from 10 down to 1. Whenever it hits 1, the watchdog is triggered, and if the watchdog was working, it would reboot the Nano, and then the countdown would start again. That's what happens in a Nuno, but it didn't happen with the Nano for me. What you'll also see is this connection here. I've grounded pin to it at the minute. My sketch has a hardware disable for the watchdog timeout, and that allows you to recover the Nano without the watchdog being triggered if you happen to possibly set a ridiculously short watchdog timeout. Okay, now let's have a look at what the code is currently doing. So if we look at the code, there isn't much to do with it. It sets up a few things. So there's the timeout, 10 seconds. It basically then sets up the watchdog, and it counts down, and if the hardware enable is well, if the pin 2 isn't grounded, the countdown will happen, and the watchdog, this reset will not happen, therefore the watchdog will be triggered. Now let's have a look at it in action. At the moment you can see that it's not working. There we go, that's better. So it's telling me the timer's disabled, so it'll just count down, and then when it hits 1, it'll count down again and again and again. That's what the disabling wire is meant to do. What I will do though is I will remove the disabling wire and restart the Nano. Then we'll see a similar countdown, but when the watchdog is not reset at the end, we will see that that's the end of our Nano. So here we go. So it's really counting down now. You can see that here. And 3, 2, 1, bark. And that's it. Notice the LED. That LED is rapidly flashing. I've lost the Nano now, so even a reset doesn't recover it for me. That's it, gone. The only way to recover it is to repower it. So if I put my short back in. Close this, repower it, bring her up. You see, we've got it back, and I'll keep doing this now because the timer's the timer reset is now back in action, so the watchdog won't be triggered. Now, next thing we're going to do is we are going to look at the Nano, or the Uno. We're going to look at the Uno now. The Uno is the programmer we're going to use. There are several ways of updating a bootloader. Thing is, you cannot do it directly. You have to use a programmer. You can get a USB programmer, or you can use another Arduino as the programmer itself, and I'm going to use an Uno to do that. It's the classic example, and I have an Uno. So the first thing we're going to do is connect the Uno to the Nano. Now we're going to be connecting from signal pins here on the Uno. This is ground and power, and we're going to be connecting to the ICSP header here. That's the little group of 6 pins, and the pin out that I'm going to be connecting to, the coloured wires, matches exactly what's on the screen. So you just give me a moment to do that, to get it in right, and then I'll connect it. I'll depower it first, and this is quite fiddly. So that looks good. Let me just check. We haven't missed any pins, and we have green is 1, red is 2, and we have blue, yellow 3, 4, then we have orange, brown 5, 6. So that's looking good. So let's think about the high fuses. We want to do the high fuses because that's what gets us our 1.5K back. Now, how do we do the high fuses? What we have to do is update a text file called boards.txt. Where does boards.txt live? Very good question. Let's go and find it. So I'll show you 2 things here. Notice I've got a different script now. Arduino ISP script. That is the script that has to be in the Uno. Okay, where do you get it? It's already in your IDE. So if you do File Examples, Example 11, Arduino ISP, that is this script. If you notice in this script also, it tells you about some other connections you can make to the Uno with some LEDs to get some status information, and indeed that's what these LEDs are here. So we've got programming error in the middle and heartbeat here at the bottom. Whenever we get the Uno going, you will see the heartbeat is sitting throbbing, which actually in this script, that's an interesting bit of code as well, which I will be looking at more. So let's get on to the boards.txt and fix some fuses. So where do you find them? Right, if you open up your preferences, while we're going through there, turn this on, this tick here. That's handy. That if there's anything goes wrong, that will give you some diagnostics output about how the upload process went or didn't. Anyway, next thing you do is click this. This brings you to a folder. Here we have it, and then you go into Packages, you go into Arduino, you go into hardware, you go into AVR, you go into 1.5. This is the right path. And here you've got boards.txt. Now, I've been here before. What I've done is I made a copy of boards.txt. So this is a copy of my boards.txt. So made a backup of it. What I'll show you to edit now is I don't need to edit boards.txt because I've done it. But what I will do is I will open up the copy, and I've highlighted some lines. These lines are the ones that we're going to change. Notice that we've found in here the Arduino Nano, and there's two of them. Okay, there's the old one, and then there's the not old one, ergo the new one. And we're going to be modifying this, and we're going to be modifying this high fuse here. So we're going to be modifying these two things. Okay, now this is the modified. I've changed the maximum size to 32256. That's 1536 bytes more than that one. That's our 1.5K. And I've changed the DA to be a DE. Okay, that's only two changes you need to make. Now, where did I get those numbers from? Well, I could have worked them out, or I could have just gone up to the Uno setting in the same file, and there they are there. So we've just copied the numbers from the Uno. Okay, so that's boards.txt updated. I've already saved mine. I've already restarted my Arduino IDE. If you haven't restarted yours after editing this text file, you should do that. Otherwise, these new values will not be picked up by the IDE. It will use the cached values from the time it did start up and read the old ones. So there we go. So what are we going to do now? What we're going to do is, if you haven't restarted it, and if you haven't restarted the IDE, do that. Next thing, if you haven't pushed this ISP sketch, Arduino ISP sketch to the Uno, do that. I have already done that, so I'm going to plug my Uno in. And then this is where we have the next fun. So notice that LED now sitting throbbing. That's the heartbeat LED. What we're going to do is program the bootloader for the Nano through the Uno. So I have to tell the programmer a few things. One, I have to tell it that we're using a Nano. I have to then tell it we're using the new bootloader. So that's that one. And then I have to tell it we're using a different programmer, and we're going to be using the Arduino as ISP, this one here. Notice there's quite a few others that look the same. You must pick this one. This is the one that works, Arduino as ISP. So I've picked that just to show you that's what we were looking at. Nano, new bootloader, programmer. Next thing we do is we burn the bootloader. That's what we do, and that's what we're going to do right now. If I make this a little bit bigger so as we can see something here, so we'll be watching the LEDs, although the burning of it's so quick, it's only 500 bytes, it's over in a flash. So what we'll do is we'll burn it right now, and it can't find COM4. Good spot. It's because we are on port of COM5. So that should be us working better. Let's check all that again. Nano, new one, COM5, because we're talking to the Uno. Programmer, burn the bootloader. There we go. Done. That's it. All done. We scroll through some of this, we see that it's lots of information. That looks fairly believable. Next thing we're going to do is check the watchdog code again. Now, that's a good point. The watchdog code was in my Nano. The watchdog testing code was in my Nano. It's not on my Nano anymore. The act of updating the bootloader wipes the rest of Flash as well. So we will have to go back to the Nano and we've burnt it. Has it worked? So let's go back to the hardware and have a look. In fact, let's go back to the script. We have to upload it, so let's unplug the Uno, take this off the Nano, and then plug the Nano in, and then we have to reset some of this stuff. So we have to put it back to that. We have to, still as Nano, we have to change it to my COM4. Where is my COM4? It would help if I plugged the Nano in. Okay. COM4. Notice I'm leaving it as the new bootloader, which also gives it 115K, and I should have selected that. Get that back for uploading my sketches, and I think we're good to go. So what I'm going to do is re-push the watchdog code. Let's upload that sketch. And I did find that when you change from one type of Arduino to another, the compile time seems to take a lot longer. I don't know why that is, so we'll leave that for a moment and we'll go back to this slideshow. Have a quick look at that, make sure what we're going to do next. Right, we're going to retry the script. We've set that, we've done all that, we're uploading it. Things we want to check for is it working at 115K? Well, if it connects with the new bootloader set, it is, and we want to see if there's more memory available for sketches. That's this 32256 instead of the 3720 maximum value, and then we'll see if it actually works. So let's see where this sketch downloading has got to. It's gone on a little bit further. Seems to be going back in time. My goodness, what is it doing? I'll have a look through this sketch anyway, show you that a bit more. Basically the setup's rather simple. It's got the test pin, that's the pin 2, whether we are disabling the timer test or not. It's got an LED, that's the onboard one. This is doing something, yes, look at that. Excellent, if we open that up, let's see what it's told us. So, it's telling us that it's connecting at that baud rate. Excellent. We see that it's down writing the flash. It's verifying it. So it's successfully talked to the Nano, and it's noticing that it's got that amount of memory, or the flash memory. So that's good. Now let's have a look and see what that is doing. So if we jump over to this larger view, you can see that that looks like the watchdog code is running nicely. And if we fire up the serial monitor, it's doing what it did before with pin 2 being grounded. So if I take pin 2 out now and restart this serial monitor, or reset the Nano probably, so if I do that and reset it, that's really doing it. Hopefully when we get to 1 we'll get the bark again, and then it'll start again and the LED won't go rapid flashing, and it's worked. Perfect. So that's the Arduino Nano bootloader updated, and it works. My work here is done. I hope this has helped you. Any questions, drop them in the comments below. This sketch, the slideshow, and anything else that I've used in this demonstration will all be on GitHub as usual. And one last thing before we go, because somebody told me I should say this, and what I'm going to say is everything worked for me, but it's all at your own risk. I'm not going to be responsible if you connect up your Nano incorrectly, get your pins back to front. But this is the second one I've done using the very same process, and I've had 2 successes out of 2. Anyway, have a great day. See you soon.